We're looking at simultaneous equations here, and the thing to know about simultaneous equations is that, well, with any equation, is if you have, so we look at the beginning one here that we did, x plus 5 is equal to 3, not too hard, we just take away 5 from both sides, and we end up with x is equal to minus 2. Or we have another example, x minus 6 is equal to 7, so we add 6 to both sides, x equals 13. That's one equation, one unknown. So it's not a problem. We can solve that, and we can solve that one. But if we have one equation with two unknowns like this, a and b, one equation, a plus b is equal to 7, this is impossible to solve. It could be that a is equal to 6 and b is equal to 1. Or it could be that a is equal to 3, b is equal to 4. They had endless possibilities, as you can see. If you have two equations with two unknowns, as long as they are the same unknowns, this is the same a as that a, this is the same b as that b, then you can solve it. And in fact, if you have three equations and three unknowns, you can solve that. Four equations, four unknowns, you can solve that, and so on. You have to have the same number of equations as you have unknowns, and then you can solve them. So let's have a look at trying to solve this one. I'm going to start off with equation 2, and I'm going to say that equation 2, so I'll do an arrow to say I'm still talking about equation 2, and I'm going to rearrange it to say that a is equal to 3 plus b, because all I did there is I added b to both sides. So so then I have a is equal to 3 plus b. Now I'm going to take this bit here and I'm going to put it into equation 1. So let's just rewrite equation 1 down here. A plus b is equal to 7. Now this b here, instead of writing, this a, I should say. Let's just move everything around a little bit. Right, I'm going to move that out there. And this a here, instead of writing a, I'm going to write 3 plus b. If a is equal to 3 plus b, then I don't need to write a. I could just write 3 plus b, right? Does that make sense? So let's just, instead of writing a, I'm going to delete a, and I'm going to put it in brackets for now, 3 plus b. So then we can say, do we need the brackets? Well, 3 plus b, if everything's plus, we don't need the brackets. So just delete those brackets. 3 plus b is equal to 7. Now we're going to simplify that. We're going to collect the terms. I'm going to say 3 plus 2b is equal to 7. And we're going to rearrange that. Do you want to see if you can rearrange that? So by rearranging that, you've got by minus 3 from both sides, you've got 2b is equal to 4, so therefore b is equal to 2 by dividing it by 2 afterwards. Awesome. Now we've got a value for b. We can go back to one of these equations, because we know that b is now equal to 2, and we can use that to solve one of these. Let's go back to equation 2. Doesn't matter which one we do now. Ideally, in theory, it shouldn't matter which one we do. If it does matter, then we've done something wrong. Let's rewrite equation 1. A minus b is equal to 3. But we know that b is actually equal to 2. So we can rewrite that as a minus 2 is equal to 3. So do you want to solve that one now? So you rearrange that and you've got a is equal to 5. So we've got b is equal to 2, a is equal to 5. So it looks like we've solved it. Now if we have, what this means is that when we put these numbers back into here, they should work out. So let's just see if that's the case. Well, a plus b is equal to 7. 2 plus 5 is equal to 7. Yeah. Now what about a minus b is equal to 3? Well, a is 5, b is 2. So 5 minus 2 is equal to 3. Awesome. So we've solved it. So we've solved our first simultaneous equation. So once again, you can solve a simultaneous equation, a simultaneous equation. You can solve a set of simultaneous equations so long as you have as many equations as you have unknowns. If you've got two unknowns, you must have two equations. There's only the odd time when they still can't be done. I'm going to show one sort of example when it can't be done. Let's say if I've got, so now I'm going to say w plus z, this is my first equation. is equal to 5, and 2w plus 2z, let's do that to show a z, is equal to 10. This can't be solved because this number 2 is exactly the same as number 1, apart from it's just times by 2. Everything's times by 2. So it's not really two equations, it's just one equation. And likewise, if it wasn't equal to 10, but it was equal to, say, something like 8, that can't be solved either. In fact, basically, equation 2, they both can't be true, because if w plus z is equal to 5, then 2w plus 2z must equal to 10, right? Or if it's true that 2w plus 2z is equal to 8, then w plus z must equal to 4. So basically, this cannot be done. So every now and again, you'll get a simultaneous equation which cannot be solved, something like this. Usually because your teacher or me, maybe I accidentally wrote an equation that can't be solved. But I don't know if you're going to get. You may get something, an exam question like that. But we're not going to bother going too much into that. We're going to really focus on the ones that can be solved first, I think. So